Today we're going to look at solving rational equations. So this is different because now we've got an equal sign. When we were working with expressions, we were only allowed to multiply by 1 because we always had to keep the value exactly the same. Well, with equations, it's different because since we have a left side and a right side, we can multiply by anything we want as long as we keep it balanced. Whatever I do to one side, I have to do to the other. As long as we do it that way, we can do whatever we want. So we don't have to multiply the top and the bottom here, as long as we do it to both sides. So the way that we solve a rational equation is to determine the LCM, just like we would if we were adding or subtracting, but we don't actually want to build the LCM. We want to cancel out all of the denominators. So that's our goal, is to get it to not have fractions anymore. We've done this before with numerical denominators. You have to be careful because remember we have excluded values. For example, on number 18, x can't be -6, x can't be +2. So if I get either of those as an answer, I have to toss it out because it's an excluded value. All right? So let's look at number 18. We need to start by factoring everything. Well, this one is factored, this one is factored, this one is x plus 6, x minus 2. That looks nice. So we need to build our LCM. The LCM in this case is going to be x plus 6, x minus 2. That covers everything possible that we have. Remember, our goal is to multiply by the LCM so that every single denominator will cancel out. So I haven't missed anything. I might have stuff left over, but we don't want to miss anything. So let's rewrite this and give ourselves some room. So we have 3 times x plus 6 plus 1 over x minus 2 equals 4 over x plus 6, x minus 2. We're going to come down here now and we're going to multiply every single one by x plus 6, x minus 2. Only on the top. And that's allowed because it is an equation. Remember, if it was an expression, no equal sign, we'd have to multiply the top and the bottom. Why do we do this? Well, let's look at what happens now. X plus 6, x plus 6. So we're left with 3 times x minus 2. Plus, these divide out, so we're left with 1 times x plus 6 equals, everything divides out over here, so that's equal to 4. If your denominators don't all divide out, then that means you didn't pick enough for your LCM. Everything should be gone if you choose the right LCM, okay? Now this is an equation that we know how to solve. So we get 3x minus 6 plus x plus 6 equals 4. Those make 0. So we get 4x equals 4, which means that x equals 1. Is 1 one of our excluded values? No. So that is the answer. Okay. So let's walk through number 19 together. We start by factoring. The only thing that needs to be factored is this one, x plus 1, x minus 1. So see if you can decide what your LCM is, and then multiply through and see if you can cancel all of those denominators. Pause your video, and I'll come back in 3 seconds. All right, hopefully you chose x plus 1, x minus 1 as your LCM. That's going to cancel everything. And so when you do your canceling, we're left with 1 times x minus 1 equals 2 times just 1, everything divided out, so that's just 2. Don't lose your minus here. That's minus 1 because that fraction was negative times x plus 1. So really we don't need these parentheses. Over here, we need to distribute the -1. So now we get x minus 1 equals 1 minus x. Well, that's kind of weird. Add x to both sides, we get 2x. Add 1 to both sides, we get 2. And we get x equals 1. That's a problem because positive 1 would make the denominator 0. That is one of our excluded values, which means we have to throw out this solution, and since there is none, that means the solution set is the null set, the empty set. We get no solution there because x is an excluded value for this equation. So no solution there after all of that work. All right, now we might see some applications of these types of problems. So number 20 is pretty straightforward. They've given us the equation. That's always helpful. So it says a company wants to increase the 10% peroxide content of its product by adding pure peroxide, which is 100%. If X liters of pure peroxide are added to 500 liters of its 10% solutions, then the new concentration, which is C, is given by this equation. Okay. How many liters of pure peroxide should be added to produce a new product that is 28% peroxide? First thing, we have to make sure we know where to plug these numbers in. So let's look at the equation here and make sure that we understand what we're looking at. Now, they told us the concentration is C. So C is the concentration. Like, how strong do we want it to be? Then they also told us X liters of pure peroxide. Okay, so that's what the X represents, is pure peroxide. So when it asks us here, how many liters of pure peroxide, that means it's asking us to solve for X, because that's what X represents. Also notice here this 0.1, that's coming from the 10% peroxide, and that tells us we need to write our percents as decimals, which we usually do. It's very rare that we do not. So the fact that they told us that we want to use, or we want to end up with 28% peroxide, that's the concentration, so that's going to be C, and we need it to equal 0.28. So we need to solve the equation. 0.28 equals X plus, we can go ahead and multiply that out. 0.1 times 500, that's 50, over X plus 500. So what do? We clear our fractions. So let's multiply by X plus 500 on both sides. And we can finish that out. So pause the video. You're probably going to need a calculator, and come back here with your solution for X in 3 seconds. All right, when you work through those decimals, distribute the 0.28, and we get this equation in the first green line. We can solve that, and we get that X equals 125. Remember with word problems that we always want to interpret our answer. So what was X? X is the liters of pure peroxide. So 125 liters of pure peroxide. That would be how we want to answer the question. Okay? This last one is a little bit trickier, but once you kind of see the pattern, it's much easier to do these types of problems. So it says, a group of friends agrees to share the cost of a $480,000 vacation condominium equally. I want to be friends with these friends. Before the purchase is made, 4 more people decide to join the group and enter this agreement. As a result, each person's share is reduced by $32,000. So we want to know how many people were in the original group. Remember, we always want to start by identifying our unknown. That's what's going to drive our equation. So the question wants to know how many people in the original group. So that's what I want to let X equal. X equal the number of people originally. Or you could say the original number of people, however you want to specify that. Okay, so let's think of this. At the start, what would be the cost of the vacation per person? Well, at the start, it's $480,000 divided by X number of people. But that number goes down by 32,000 because that is equal to, now what happens if you take 480,000 and instead of dividing it by the original X number of people, we divide it by X plus 4 because 4 people joined in, okay? That's the equation that we want to set up. Again, this is the original cost per person, and then the 32,000 is the amount less from what the original cost was. On the right-hand side, this expression represents the new cost per person. And so that's kind of where that equation comes from. I'm going to leave this for you to work out and try on your own, but I can tell you that the answer you should get, pause it if you don't want the spoiler, is that there were 10 people in the original group. Okay. So the idea here, again, if you think, and I'm just doing this in my calculator right now, so if 10 people were in the original group, originally it was 480,000 divided by 10, so that was $48,000 per person. But then when they went, instead of 10 to 14, now if we divide that by 14, it's about 34,000. So we can see that that decreased by quite a bit. So that is nice for them. I don't have a vacation home to share with anybody. But so that is how that problem works. And you'll see a couple like that, but not a ton. So good luck with those. Let me know what questions you have, and I'll see you next time.